Hello, thanks for tuning in to Comfort-Calc's newest information-filled short seminar. We're going to talk about outdoor reset and boiler modulation, how they work together. When you use high-efficiency boilers, you should have an outdoor sensor, but a lot of people don't understand what it actually does, what the sensor does, how it communicates to the control, what happens with the boiler when we start sensing outside air temperature. So we're going to give you the ins and outs in probably 10 minutes or less. So just sit back, enjoy the seminar, and let's talk about outdoor reset. So what is outdoor reset? Outdoor reset will change the water temperature of the system as the outside air changes. This is a picture from December of 2022 near Lake Erie. If these houses had outdoor reset, unfortunately, it probably wouldn't work very well because they're covered in ice and snow. One thing about outdoor reset, the outdoor sensor must sense air temperature. If it can't, it will change the temperature of the water where it may not heat the house properly. But manufacturers include a thing called boost. And we're going to talk about how the outdoor sensor sends a signal back to the boiler, changes the supply water temperature, and if it can't heat the house properly, it's going to boost automatically. Now that boost could be turned on or off. If it is on, it will definitely save you in a situation like this. I'm not sure about where you live. I've lived in Pennsylvania for my entire life, almost 70 years, and I've never seen this in our area. Of course, in Erie, which is also in Pennsylvania, they have seen it. So that would be the once in a 50-year situation where outdoor reset doesn't work in your area. For outdoor reset to work properly, we have to constantly monitor the outdoor air temperature. We could hang a thermometer on the wall outside, but it's not going to communicate to the boiler. It's not going to send a signal back so the boiler knows where to set the supply water temperature to heat the home properly. So we would have to use something else. When we have that sensor mounted outside, it's going to send a signal back to the boiler via wire or wireless, and it's going to automatically change the water temperature going out to your heating system to properly heat your house at any given temperature. There's an algorithm built into the boiler control and parameters that control what's going on to tell the boiler at a given temperature, I'm going to supply this temperature water. The manufacturers have actually done a pretty good job of setting that algorithm out of the box to work fairly well anywhere in the country. But it could be dialed in to better work in your area with your home, with your type of radiation, with your heat loss. So all this comes into play to make sure that the boiler heats the home properly, keeps you comfortable all the time, and saves you the maximum amount of money. This slide is just more of a tip. Uh, the sensors outside, there's a lot of them that are going to look different. They're going to be round, they're going to be square, they're going to be rectangular, they're going to be larger, they're going to be smaller. But it has to be a sensor outside that sends that signal back to the boiler. And when that's installed, I've seen some of those installed upside down. Does it matter as far as sensing air temperature that it's upside down? No. It could be anywhere, it could be dangling in the air, it doesn't matter. But we want to keep the water out of it. We want to keep the rain out of it. And I've seen situations where the hole was drilled through the wall. They cocked the hole shut. The wire went down the top of the sensor, and that was how it was left. Then some years later, the sensor fails, and that's because it was upside down. Water got into the sensor. The wire should always come into the back or into the bottom of the sensor. There is a little rubber grommet there, but we got to mount that sensor so that the wire comes out the bottom if you're going to use the bottom entrance, but never in the top. And then when the wire comes out of the bottom, you should make a little loop in it. And that way, when it's raining and the water's coming down across this sensor, it hits that wire and drops off. Then we can go back up and go into the wall, seal the little hole shut, and you're done. But you've got to keep the water out of the sensor. That's just a quick tip while we're talking about outdoor reset. Mounting the outdoor sensor, we have to be cognizant of where we put it. We don't want it in sunlight. We don't want it in a lot of places it's going to be affected. We'll discuss them in a second, but just find a good place on the house to put it. It's not very big again. Right now we have it on the front side of the house right here. And it's, again, not much bigger than your thumb. So it's not an eyesore to see this thing as you pass the house. More and more houses are getting them. Now, the problem is a lot of high efficiency boilers don't have outdoor sensors on them anymore. They've been removed. That takes money out of your pocketbook. We really need to use an outdoor sensor if we're using a high efficiency boiler. Many boilers had it installed and disconnected it. Why? Because it doesn't work in my area. That's not true. It's because the settings weren't right in the boiler. Or maybe as a homeowner, they weren't told that what the outdoor sensor does and how the boiler works. They may be expecting 180-degree water in that baseboard and it's as hot as it's always been. That doesn't happen with high efficiency boilers that are properly working, properly set up. You're going to have varying temperatures off that radiation. And that's part of the sales point. They have to be told that it's not going to be as hot as it always was. But if they look at the thermostat and it's 70 degrees in the house and it's set at 70 degrees, it's working. If they're not warm enough, turn it up. And one of those reasons they may not think they're warm enough is because at 68, the old thermostat may have been comfortable. Well, it may not have been accurate. Every thermostat has a little variance built into it. When we had mercury style thermostats years ago, there'd be a lot of dirt built up on that mercury through the years and it would become off. And people would say, I keep my house at 65 and I'm always comfortable. Now I get a new boiler and I put it at 70 and I'm still chilly. Well, turn it up. I always say thermostats should not have numbers on them. Just set them to where you're comfortable and leave it there. With outdoor reset, you don't want to be changing the temperature up and down frequently. You just want to set it and forget it, as Ron Popeil would say. So let's look at where we should mount these sensors and where we should not mount the sensors. Again, mount it in a shaded area, mount it out of the sunlight, keep away from heat sources. We're talking about dryer vents. If the wind blowing across that dryer vent towards the sensor and the dryer is running, guess what? The water temperature in the system is not going to be as hot. So therefore, you're not going to get as much heat out of it. Now, what about furnace vents or boiler vents? The wind changes direction. Don't be in line with one of these things because it's going to make the house cooler. Heat pumps. Heat pumps do put off heat when they go into defrost. So as that heat's coming out, blowing across your sensor, it's going to change your system water temperature. Keep it above snow levels. They have to measure air temperature, and that means they cannot be blocked by snow. If you get blocked by snow, it's going to stay the same temperature under there, fairly close, because you've got a little heat loss off the house. The snow's got this thing buried, and it's not going to change with the air temperature. You got to get it above the snow line. And just use your head in putting this. If you have to put it on a side that catches a little bit of morning sun, maybe get it in the shadows. Maybe have it, there's a bush in front of it or something that will break the sunlight from hitting it directly. But you have to pay attention where you're putting these sensors for proper operation. If we don't place the sensor in the right location to start with, we're going to fool that boiler into thinking it's a different temperature and that house is going to be cool. If the boiler could think, it would say, I'm going to save them money, I'm turning the water temperature down, but in reality, the sun's beating on the sensor. So you're uncomfortable, the boiler's happy, it's giving you the right supply temperature, and you're upset. So the boiler's happy, you're not. Get that thing where it needs to be, get that sensor installed at the right place so it's not being fooled into giving a false water temperature. The outdoor sensor sends a resistance back onto the boiler that changes as the temperatures go up and down. The boiler receives that resistance and determines a supply water temperature. And the hotter the outdoor air temperature, the lower the boiler water temperature. The lower the outdoor temperature, the higher the boiler water temperature. So it's going to monitor this all the time, 24 hours a day, constantly. As soon as the outside air changes, the supply water temperature changes. So we're going to see these temperatures change from one extreme to the other as it gets colder, and just small amounts throughout the warmer weather. So it gets really cold outside, and the water temperature in the boiler goes up. It's going to find that set point temperature and changes, the air temperature changes, just as you just seen on the slide. So it's going to do this all the time. It doesn't check it once an hour. It doesn't check it once every 30 minutes. It monitors it constantly and constantly makes the changes it needs to. If we get a quick cool snap in 15 minutes, it changes by 20 degrees, it's going to pick that up and make those temperature changes immediately. Manufacturers have given us a thing called boost. Now, boost can be our friend, but it could be our enemy. It can be our friend if we never use it. Think about that. It could be our friend if we never use it. But if we use it all the time, it can be our enemy. And what I'm referring to is the dollars we spend for fuel. If we don't use boost, that means that we're heating the house at lower water temperatures and we're saving money. We're inputting less fuel to maintain those temperatures. But when it starts boosting, now it's costing us more money, because as the water temperature in the boiler goes up, the efficiency on the boiler goes down. So the cooler we run the boiler, the more efficient it is. The warmer we run the boiler, the less efficient it is. Now, there's another part to that, and that's modulation. We'll talk about that a little bit later. So we're not always inputting 100% of the fuel. So what boost does is, let's just use a scenario of 30 degrees outside, 150 degree water temperature as a set point. A set point is the temperature the supply water the control is targeting. So it's trying to get to 150 in this example. So right now we're running at 150, and we're running that boiler along, and it's struggling to heat the home for some reason. So what we do is we have boost that can come on and start giving us warmer water. And these numbers are going to change a little bit from manufacturer to manufacturer, and the times are usually adjustable, and I don't want them too close together, like 5 minutes. But let's assume that every 10 minutes that water temperature, or every 20 minutes that water temperature changes 10 degrees. So we're targeting a set point. And let's say that set point again is 150. So if that thermostat is calling for 20 minutes, it's going to raise that temperature by 10 degrees. And another 20 minutes, going to go up another 10 degrees. Another 20 minutes, another 10 degrees, until it gets to the maximum temperature the boiler is allowed to operate at. And that's normally 180 degrees in high efficiency boilers. But remember what happens. When we boost up, our efficiency goes down. Now we're still modulating, so we're still saving money. But if we could operate it cooler, we would be more efficient. We would save more money. So boost, again, can be our friend. There's manufacturers that will default boost on, and manufacturers that will default boost off. So if it's off and the house, excuse me, and the house is a little shy on radiation or insulation, then we would be boosting more often. But we can compensate in the control parameters for a lot of this too. We can just say, hey, let's just make that house supply water temperature 5 degrees warmer. And guess what? 5 degrees in your radiation makes a difference depending how much you have. The more radiation you have above your heat loss, the more difference it makes. So you can actually work a lot cooler water temperature if you have more radiation than your heat loss. So the amount of radiation put in that home when the house was built, and you've put new windows in, and you've put new doors on, and you maybe added some insulation, you've dropped the heat loss, and now you have more radiation than what you had before, because most houses are over-radiated. So therefore, you can drop that water temperature maybe even more if you start tightening up your home. Now, I would always suggest you do that first, but it doesn't always happen that way due to boiler failures. So boost is our friend, but it can be our enemy, as I said. If we have that large radiator system, it takes a while to heat up, it's going to boost. So maybe I don't want boost on. Maybe I'd rather just boost that water temperature myself for 5 degrees or 6 degrees and leave it go at that and let it work at a little bit higher water temperature all winter. And that may take care of it. Maybe we need 180 degrees at 10 degrees instead of 0 outside because we're a little light on radiation. Again, make the change in the parameters. Don't disconnect outdoor reset. Uh, do install the outdoor sensor time the boiler is installed, and beware of the use of boost. Again, you can use it or you don't need it, but don't have it change 10 degrees every 5 minutes. That just doesn't work. It's just too close. You might as well not have the sensor. It's going to cost the homeowner more money. So keep boost at 20 minutes if you're going to use it. I would say if it's on, turn it off. If it's off, leave it off. And let's see if the customer needs it. Again, if most boilers are oversized a lot, so you may not really need it. But we might need it in some of those homes that are a little drafty yet, and maybe not enough insulation. They may need it, but let's not use it if we don't really need it. So let's talk about modulation. Modulation is just the fan speeding up or slowing down. That's all it is. So you say, how does that affect my boiler? How's that save me fuel? Because as we're changing fan speeds, we're changing the amount of gas going into the boiler. This isn't the old style boiler. This doesn't have a positive outlet gas pressure where it's always set at 3.5 inches in a cast iron boiler for natural gas coming out of the gas valve. That's not how this works. This is what we call a negative pressure gas valve. Some people call it a zero pressure gas valve. But the gas valve is going to always be 0 or slightly negative. As the fan speeds up, it pulls more gas through the gas valve. As the fan slows down, it pulls less gas through the gas valve. So therefore, we're going to have a larger fire or we're going to have a smaller fire. And that's how we modulate the boiler to maintain our water temperature. So that modulation is going to go up, pulling more gas as we have to make up maybe 20 or 30 degree water temperature when the thermostat first demands. So we're going to maybe run that boiler up to 100% and just jam a lot of gas in there, get that water heated up really fast. And then as we get closer to what we call our set point temperature, we're going to slow that gas down. We're going to slow that fan down, pull in less gas, and try to maintain that temperature. The best operating high efficiency boiler is one that just operates almost all the time. Anytime there's a thermostat in demand, we're going to keep that boiler running. We don't want the boiler shutting off while the thermostat still has demand on the boiler. Or maybe we have a thermostat running and another thermostat kicks on, and then the first thermostat satisfies. That boiler should stay running. We don't want to heat that water up too fast to where we hit the set point temperature and the boiler shuts off. And that can happen a lot with oversized boilers. Modulating boilers need to have a heat loss done or some type of calculation to determine the right boiler size. When that boiler is too large, it can't turn low enough to maintain that temperature and therefore shuts off. So what happens when it shuts off? Your fan goes into a post purge, blows a lot of heat to the outside. Finally, the fan shuts off. Boiler cools off. Now the fan comes back on and starts blowing heat to the outside out of the water temperature passing through the heat exchanger. So we're throwing a lot of BTUs to the outside that we already created. But if we keep the boiler running at a lower input, meaning a lower fan speed, we're actually going to send less BTUs out the vent because we're going to be at a minimum fire. I mean, that fan is not moving much air through that heat exchanger at that point. So we're trying to utilize as much heat as possible by leaving it running. You're actually going to use more fuel by starting and stopping the boiler. So size the boiler properly, leave it running. Homeowners may not understand that it's more efficient to stay running. And since we can modulate it, it makes all the sense in the world to just leave it run. If this was a cast iron boiler running at 100% all the time, do I want it to shut off? Not really, but it will. That's the nature of the beast. You're going to hit those temperatures. Do I want it to turn off every 5 minutes and then come back on, run for 5 minutes, shut off for 5 minutes? No, that cast iron boiler, I'd rather see it run 10 or 15 or 20 minutes because it's the proper size. So on these high efficiency boilers, the longer they run, the more efficient they are. Now we can still cycle off that thermostat and have that boiler shut down. But again, if I can't get 20, 30, 50, 60 minutes out of this runtime, I'm assuming the boiler is too big. So just make sure we size them right. Let the fan do its thing, pulling in as much gas as we need. Leave it running at minimum input. I mean, if you have a 10-to-1 turn down boiler, that means you take the input and divide it by 10, and that's your minimum output. So 100,000 BTU boiler divided by 10 is 10,000. So if I'm running that boiler at 10,000 BTUs for 10 minutes, that's a big savings compared to running that boiler on and off in that time period and taking longer to satisfy the house. Because if the boiler's not running, it's not heating. So if we can keep it running at this low input and stop that blowing the BTUs outside with the fan when it's not running, because when that boiler shuts off, the fan speeds up before it shuts off at the end of the cycle. And then when it comes back on, the fan's running at a higher RPM, and then it goes to the ignition speed, and then it modulates where it has to. But to keep it at low fire, it's like trying to heat your home with a candle. It's going to save a ton of money. Let's try and explain modulation. We have a set point on the boiler, and that's according to outside air temperature where we need to be. So we're going to modulate that fan to maintain that set point, but we got to get there. We got to light the boiler, we got to get the water heated up to 150, and then we got to modulate it around to maintain that 150 set point. So every fan has an ignition rate. That ignition RPM, ignition speed, call it what you want, but it's where the boiler lights off. It's going to go there, and then it's going to light, and it's going to prove flame, and then it's either going to turn up or down depending on the manufacturer. Some will light it off, go up to high speed, let it run at high speed until it needs to modulate back. Some will come on, drop down to a minimum speed for a couple of minutes and let the water temperature heat up a little bit, and it'll only go where it needs to go. So it may not hardly ever see high speed unless we really have cold water coming back for a long time. So as this boiler is trying to get to the set point temperature, we're going to see this fan speed changing throughout the cycle. And depending on what the water temperature is and where it has to go, all that changes. But let's try and show this modulation. So we're trying to get to set point. The fan goes up to the ignition RPMs, and then once it lights, proves flame, it goes way up, and then it's going to stay there till it warms the water up enough, and then it's going to modulate back. Now it's going to stay there till it modulates that set point temperature and just maintains it. And if that thermostat's demanding for 15 minutes, it's going to keep that water temperature where it is 15 minutes. Let's say that a cold front blows through and it drops 5 degrees outside in a matter of minutes during that demand on that thermostat. I know it's pretty unlikely, but let's say it does. It's going to raise that water temperature because it dropped outside. Even though the fan's running, it's going to change that water temperature, and you're going to see the fan RPMs actually bump up a little bit. And then it's going to drop back down because we've hit that new temperature. We talked about boost. If it goes into boost and we have to raise that water temperature 10 degrees, it's going to speed the fan up, bring in more gas, burn more gas, and then another 20 minutes, it's going to go up again 10 degrees. So the modulation is going to speed up. It's going to get close. It's going to get to that set point. It's going to drop back down. It may only go up 1,000 RPMs, but that's all it may need to get to that next level if we have boost turned on. So just, again, beware boost. With overlapping thermostats, multiple zones in the house, you're going to be boosting all the time. I would not run boost if I have more than 2 or 3 thermostats in the house. But again, that's my opinion after 45 years in this industry, working for a manufacturer, knowing these products, being around them for the last, 15 years, whatever. So I don't like boost. I don't use boost. Modulation is great. I want to see the boiler running. I want to see it running at minimum input as much as possible. So hopefully that gives you a little understanding of modulation. I did say that some manufacturers will turn the fan speed down at first. Um, let's say the boiler starts and there's another zone running. It's going to go to whatever water temperature it needs. When that water starts coming back from that zone it just turned on, the water temperature is going to drop in the system as that cool water blends with the other water that's coming back from a warmer zone. And you're going to see the fan speed up a little bit and then go back down, and it brings the water temperature up. That's all normal. But on light off, some of the manufacturers will drop the RPMs of the fan to minimum. And the reason they do that is let's run that water through the system a little bit and let's get it warmed up through low fire, and then let's speed it up where it needs to go. Instead of going to high fire right away and start wasting fuel, let's just let it go where it needs to go after we warm it up a little bit and keep it away from high fire. That's where the most of the fuel would be used. So we're going to start everything off. It's going to start warming up the system. We're going to drop to low. We're going to slow down that water temperature rise, and then we're going to go up where we need to. It may not go all the way up to max RPMs. And then when we get close to set point, we're going to still lower that fan speed and start saving money again. Thanks for viewing this seminar. If you like the seminar, please go ahead and hit like. We're just starting new YouTube stuff. We got to get that algorithm moving so people search on stuff, they can find us. So just smash that like button and subscribe if you want, so you can see newer seminars. I've got a couple new ones I'm putting together that we'll see shortly. Or if you want more in-depth training on these products and piping and pipe sizing and circulator sizing and venting boilers and just everything about boilers, visit us at Comfort-Calc.com. Remember, there is a dash in between Comfort and Calc. Comfort-Calc.com. Go to our menus listing and see the plethora of seminars that we offer, pre-recorded, in depth. Thank you.